back. So now we look at problems from section 2.8. Problem 1. Okay, suppose xy is -3, dy dt is -4. Find dx dt when x is 3. So a whole bunch of information is given to you. So let's write that down. Xy is -3. X is 3. Okay. So one thing is when x is 3, I plug in 3 here. How do I get -3? Y has to be -1. So I will need both of these things. Now look at this function. Look at this, equation. Take derivative with respect to time. That's what they have given us, right? Of both sides. Left hand side is product rule. So derivative of x with respect to time, y as it is plus x as it is times derivative of y with respect to time. Right hand side is derivative of -3, that's 0. Now, you are told when x is 3, you want to find dx dt. Alright. So dx dt, when x is 3, y is -1. So y becomes -1. dy dt is given to be -4. Plugging it all in, notice this is multiplication, so negative dx dt minus 12 is 0. That means moving dx dt to the other side, or however you like, dx dt is -12. Next problem. A baseball diamond is a square with sides of length 90 feet. A batter hits the ball and runs towards first base with a speed of 20 feet per second. At what rate is his distance from second base changing when he is halfway to the first base? When he is halfway to the first base. So let's go. Let's look at the picture. I would like to show the picture. So you have a baseball, okay, baseball diamond is a square. So what is that? So let's maybe make it better here. So that's a baseball diamond. So a batter is standing here. First base, second base, third base. He has hit the ball, it's gone wherever, and he's running towards the first base. So that distance that he has run is x feet. This is baseball diamond. It is a square, 90, 90, 90, 90. So if this is x, the leftover is 90 minus x. Question is, what is the rate of change of the distance from the second base to the batter? Right? Is his distance from the second base changing? All right. So, given this picture, well, that's a right triangle because you are told this is a square. So that is 90 degree. So, in this direction, he is running at the speed of 20 feet per second. That's given to me. He is running with a speed of 20 feet per second. So this distance is changing at the rate of 20 feet per second. All right. Now, what about relationship between d and x? Well, that's a right triangle. So d squared, because d being hypotenuse, is 90 minus x quantity squared plus 90 squared. Now you take derivative of both sides with respect to time t. This is chain rule. So 2d dd by dt equals 290 minus x. Derivative of the object inside, look, there is a negative, so 90 dx dt. This is constant, its derivative is 0. Now, let's look at this. I have a 2 here, I have a 2 here, so divide both sides by 2. I get d dd by dt equals 90 minus x times negative dx dt. Now, when the runner is halfway to the first base, so that's the first base, it's all 90. So halfway means 45. X is 45. So I'm going to plug in 45 for X. So 90 minus 45 is 45 squared, and that's 90 squared. I get capital D. It is square root of all this. So X is 45, so that's 45. Dx dt we are told is 20. So negative dx dt is negative 20. And this capital D we just calculated using Pythagorean is this quantity. So dd by dt, you take this right hand side, divide by this. So that's where I have negative 900 over square root of 90 squared plus 45 squared, square root. Okay. Now, second part of the question, at what rate is his distance from the third base change? So my third base is over here. So let's repeat this picture again. There you go. So he is running in this direction. Dx dt is still 20. Now from the third base, that's now my capital D. So d squared is now x squared plus 90 squared. Take derivative. All right. Divide both sides by 2. All right. When the runner is halfway to the first base, right, x is 45. So my capital D is the same thing as before. All right. So instead of negative, I have positive. That's all. So it's the same expression, except instead of negative, it's positive. All the other calculations continue. All right. That's correct. So next video, we'll start on problem 3. Until then.